In this example for section 13.7, we're given the equation of a surface and we want to find the equation of the tangent plane and parametric equations for the normal line at the given point. Now we want to come up with a function, that capital F of x, y, z function, a function of three variables, all of that equals 0. In order to do that, we're going to first subtract z from both sides of the equation. So we get this capital F of x, y, z function equals x squared minus 2xy plus y squared minus z. All of that is equal to 0. Now the gradient of that is going to be used as your components of the normal vector. So the gradient of f of x, y, z is found by taking the partial derivative with respect to x. That partial derivative with respect to x is going to be 2x minus 2y. Now we're going to take the partial derivative of this with respect to y. Treat y as a variable, treat everything else as a constant. That derivative is going to be negative 2x plus 2y. And then that's your j plus the partial derivative of all this with respect to z, and that derivative is going to be negative 1. That's times your k. Now we're going to evaluate the gradient at the given point. The gradient evaluated at the point 1, 2, 1. You're going to plug in 1 for x and 2 for y and 1 for z, and when you simplify that, you get your negative 2i plus 2j minus 1k. So that's going to be your components. You can write it in the angle bracket notation, negative 2, 2, and negative 1. That is going to be your ABC components of the normal vector. So we're going to use now the normal vector and the given point. The point is going to be, that is going to be your x sub 0, y sub 0, and z sub 0. We're going to plug in those into the equation of a plane. So our tangent plane is going to be a, which is negative 2 times x minus 1 plus 2 times y minus 2 minus 1 times z minus 1 equals 0. And again, I'm using for A, B, and C. For A, B, and C, I'm using the A, the B, and the C as the coefficients. And then for your points, you're using the minus 1, the minus 2, and the minus 1. Now you can distribute, simplify this to get another equivalent equation for the tangent plane. Now we're going to go ahead and find the equation for the normal line. So for the normal line, these are parametric equations, so it's pairs of equations. Those equations will be x is equal to your starting x, would be the x on the point, minus your 2t, that's from the normal vector. Your y is equal to your starting y from the point, plus 2t, and then your z is equal to your starting z1 minus 1t. So those would be the parametric equations for the normal line at the given point on that surface.